Assalamualaikum to Dr. Rozamri. Today, we are going to present on the treatment of a few contaminants that can be found in the industries. But before that, let me introduce you to our fellow group members. Group 10 consists of 6 members. The first member is Tan Kai Hui with metric number 203116. The second member, which is me, Naili binti Shamudin, with metric number 204543. The third member is Nur Atirah binti Muhammad Ishaq with metric number 204622. Our fourth member is Nur Alia Shahira binti Rahim with her metric number is 203340. And our fifth member is Sufia binti Zainal with the metric number 204600. Our sixth or last member is Zairin Sulaika binti Zulkifli with metric number 204665. Me, Naili Shamudin, with metric number 204543, will be presenting on the introduction of our topic for today. In this presentation, we are going to discuss about 4 contaminants. They are pesticides, herbicides, color and pigments, heavy metals, and fats and oil. Before introducing deeper into those contaminants, I would like to explain about wastewater and how crucial it is for wastewater to be treated before being removed to the environment. Wastewater is the water that contains different types of materials that are known as contaminants or pollutants. The wastewater can be identified as used water, or some refer the term as sewage. The contaminants in wastewater can be human and animal waste, the waste from our food, chemicals such as soap, detergents, and also microorganisms such as pathogens as well as viruses. We may categorize the properties of contaminants either physically, chemically, or biologically. The different categories have specific characteristics that need to be determined in order for a treatment to be effective. Treating the wastewater is so important because it helps in protecting humans and our ecosystem. Well, economically effective wastewater treatment has important effects on saving water and preventing unnecessary water losses. It is amazing how there are many techniques invented to treat such complex materials with different sizes and different physical chemical properties. So from this slide, we can see that different categories have specific different treatment that can be applied to produce clean effluent. The overall treatment process can be grouped into steps, which the first step is the primary treatment. The second step is secondary treatment, while the last step is tertiary treatment, where this treatment is actually optional. The first treatment is the treatment where it acts to remove suspended solids. Then the water will flow into the system until it reaches a secondary treatment, where usually microbes are used to reduce the BOD and remove color and oil. Well, last step is an optional step to further treat the water from remaining contaminants to produce purified effluent. Why does the wastewater from different industries need to be treated? Of course, it is to produce clean effluent before releasing it into the environment. Secondly, it is to practice sustainability in using and maintaining the water source. This is because some regions around the world face issues such as high water demand and low yearly rainfall. So by treating the wastewater, we can reuse the clean effluent. This is where the sustainability practice is applied, and we can achieve the long-term solution to the water shortage crisis. The wastewater needs to be treated because water is an easy medium for any particles or materials to use to move and spread themselves, be it chemical, physical, and especially biological pollutants. Water is a medium that harbor all the pollutants such as harmful chemicals and diseases that can disrupt the livings on the earth. Therefore, by treating water, we can ensure the minimization of public health risks, and also we can conserve the wildlife habitat.
As we know, polluted water can come from various sources. One of it is the color and pigment. Therefore, in order to reduce the harm that causes by this color and pigment, there are many technologies and also treatment needed in order to control its negative impact on our environment. First of all, let me define to you what is the meaning of colors. Color or colorant is actually defined as a substance that is capable of transmitting its color to the substrates. Colorant is used in a variety type of industry, which includes clothing industry, ceramic, paint, plastic, photograph, and also food industry. Colors actually can be used on their own or in the conjunction with other ingredients to change the color of the final products. Due to the visual perception of colors that is caused by the absorption or reflection of visible lights, it will help to make the final product looks more appetizing and attractive. This same goes to the food. Whenever we see the food is full of colors, it actually helps the food to look more appetizing. So, what is defined by the dye? Dye is defined as the organic compound or a mixture that are used for sharing its color to the substrate, which are cloth, paper, leather, and other materials. A good dye is considered to have a suitable and attractive colors, property to bind itself to the substrates, water soluble, and also have the affinity toward the substrates. So, how does the dye have a colors? Dye have a colors because it absorbs light from the UV spectrum that has the chromophore and also conjugate system. And then it has the electron resonance that contain isochromes. The uses of dye is determined by the structure of its dye itself. So the dye actually dissolves in the aqueous solution to improve its fastness on the dye substrates. Dye can be classified on their basis of structure and also application. So what is the pigment? Pigment and dyes are actually derived from the same building block but differ with their solubility factor, where dye are more soluble in the media in which it is incorporated while the pigment are not. A basic physical pigment requires mixing with the medium. It is actually a liquid-based powdered substance and employed for the coating surfaces. Typically, both of them are insoluble in both organic and inorganic material substance. However, due to their high permanency and high pigment content, they can alter the appearance of a product or a substance by elective absorption or by scattering of the lights. Next, I will talk about organic pigments. Organic pigment is actually based on the carbon change of rings that contain metallic element and helps to keep the components stable. Their chemical structure, surface properties, crystallinity, particle size, and also size distribution will affect how well it performs. Next, I will talk about inorganic pigment. Inorganic pigment are the solution of metallic salt precipitation and not based on the carbon. Even though the pigment are in the precipitated form, the raw pigment materials will require further processing like mechanicals, heating, or chemical treatment in order to make them as a more useful materials. Inorganic pigment also can be considered opaque due to its optimum particle size. There are many kinds of industry that use color in pigments. However, on today, we will be focusing on the food industry. So why does this color and pigment being used in our food industry? Basically, they are used for the purpose of enhancing the color of the existing foods and also to avoid the color loss due to environmental factor, while at the same time will increase the shelf life stability of the products and also being used to provide the consistency when there is a variation in the food colors. When all of this can be done, it actually will provide the appealing or appetizing to the food products. There are two types of the coloring often being used, which are natural and also synthetic colorants. For the natural colors, it's actually derived naturally from plants, insects, or bugs. Next one is the artificial color. So artificial color are actually a food additive that are used to provide or enhance the characteristics of the colors in the food products. They can be obtained from the synthetic process. In other words, they are actually the substance derived from the chemical ingredients. They are made up typically from three main components, which are complex hydrocarbons, nitrogen, and also sulfur ions. Most of the times, artificial color additive needs to be registered or administered under the US Food and Drug Administrations. In comparison with the naturally extracted colors, as I said just now, Artificial color are more stable, economical, and available in the wider varieties of color.
For the treatment of coloring, I will highlight 4 treatments that are conventional and are known to be inexpensive and easy to handle. The methods include coagulation, membrane treatment, biological treatment, and adsorption. Coagulation is a physical-chemical process. It is a process involving changes in the physical properties and chemical structure of substances by neutralizing the anionic particles by adding cationic salts. So the coagulant additive or chemicals that are usually mentioned and utilized in journals include ferric chloride, ferrous sulfate, ferric sulfate, alum, lime, and also polymers, or even combination of these chemicals. This process is simple, inexpensive, and can handle large concentration of wastewater containing dyes. The second treatment to remove color is membrane treatment. The mechanism involved is separation technique by electrostatic repulsion. So this technique is highly efficient and low in cost comparison with other advanced treatment. There are many techniques of membrane treatment that is recently introduced, such as nanotechnology. However, the disadvantage of this treatment was reported in terms of the accumulation of foulants in the membrane, that it reduces the efficiency of the membrane to select and permeate the materials such as color and dyes. Adsorption is the next treatment in which it can treat color in the wastewater by combining the process of separation and purification using activated carbon as the universal adsorbent. So activated carbon, the properties of this universal adsorbent will influence the treatment efficiency. But then we have other optional adsorbents such as biosorbents. The examples include microbes and also industrial byproducts such as rice husk, seeds, and also pulp. And then we also have nanomaterials, in which those materials that have the properties where the materials are smaller than 100 nanometer and have high selectivity. The next adsorbent is carbon nanotubes. This adsorbent was reported to be more economical than activated carbon, where the usage of it can be lower in amount to treat the pollutants in water. So adsorption is a method that is simple to operate, versatile, as well as inexpensive. The last treatment is biological treatment. Pigments and dyes can be treated biologically using either living organisms or dead biomass. So by using them, the pollutants are adsorbed and can be converted through their metabolic pathways into simpler compounds such as salts, carbon dioxide gas, and also water. And this method is considered to be eco-friendly, also versatile, economical, and inexpensive. For example, the cell wall of algae can act as a filter of pollutants such as color due to the presence of hydroxyl, carboxylate, amino, and phosphate in the cell wall.
I will talk about properties of pesticide and herbicide. So what is pesticides? Pesticides are actually the substance that are used to control the pest. It includes herbicide, insecticides, and also fungicides. So what is herbicides? Herbicide is actually a substance that are often used to destroy the weeds and also unwanted vegetations. So both properties of this substance is actually depends on their solubility, absorption, persistence, and volatilities. Its properties actually will determine its usage and effects on the environment. Therefore, it is very crucial to understand the chemicals and the physical characteristics of both substances to allow the applicator to make better decisions about which active ingredients or formulation to be used in the particular situations.
There are many industries that use pesticides and herbicides. You can note that most industries involve the plantation and processing of food commodities such as agriculture, fruits and vegetable processing plant, and food crops plantation. Other than that, pesticides and herbicides can also be found in wastewater coming from factories producing them. Now, we will look into the treatment methods on pesticides and herbicides in wastewater. The methods are divided into 4 categories. The first one is chemical treatment. One example is chlorination. Chlorination is cheap and easy, mainly targeting 4-organophosphorus pesticides. Another example is advanced oxidation processes, which works by degrading organic contaminants into harmless products. Next treatment method is by applying biological treatment. Two most common methods are bio-augmented activated sludge and membrane bioreactor. Bio-augmented activated sludge uses conventional activated sludge augmented by 2,4-dichlorophenol degrading bacteria, while membrane bioreactor is a latest technology that combines membrane filtration technique with biological treatment. Pesticides and herbicides in wastewater can also be treated with physical treatment and hybrid technologies which combine chemical, biological, or physical treatment.
Heavy metals are generally defined as environmentally stable elements of high specific gravity and atomic weight. They have such characteristics as metallic elements that have a high atomic weight and relatively high density compared to water. While the chemical forms of heavy metals can be changed, they are not subject to chemical or biological destruction. Therefore, after releasing into the environment, they are persistent contaminants. Unlike organic pollutants, heavy metals are non-biodegradable and have the tendency to accumulate in living beings. In fact, most of them are known to be potential carcinogens. Heavy metals are usually present in trace amounts in natural waters, but many of them are toxic even at very low concentration. Metals such as cobalt, copper, iron, mercury, arsenic, lead, cadmium, nickel, chromium, zinc, and selenium are highly toxic even in minor quantities. Heavy metals can contaminate private wells through groundwater movement and surface water seepage and runoff. Most of these metals end up accumulating in the soil and sediments of water bodies. Heavy metals can be found in traces in water sources and still be very toxic, and impose serious health problems to human and other ecosystems. This will be impacting those people that consume high levels of heavy metals as they are risk acute and chronic toxicity, liver, kidney and intestinal damage, anemia and also cancer.
The volume of discharge effluent from industrial and agricultural activities is so large that negatively impact the water quality and also the food supply chain. Various industries that generate industrial wastewater containing heavy metals. For example, industries such as electroplating and metal surface treatment processes. This industry usually will generate heavy metals such as cadmium, zinc, and lead. Furthermore, another significant source of heavy metal waste can be found in the industry of production of printed circuit boards. The most common resistant overplates are tin, lead, and nickel. Moreover, the industries that generate the metal waste and found in the wastewater are the wood processing industry. This wood processing industry produce arsenic-containing waste from chromated copper arsenic wood treatment. Next, the industry that can produces the conversion catalyst contaminated with nickel and also the chromium is the oil refining industry. All of these mentioned industry produce a large quantity of wastewater containing heavy metals that can be categorized as hazardous waste, requires extensive waste treatment. So, how are we going to treat the heavy metals in the wastewater? First, we can use chemical precipitation. It is the method where involve the addition of chemical reagent followed by the separation of the precipitated solid from the clean water. Metal precipitation is accomplished through the addition of coagulants such as alum, lime, and iron salts. The second method I would like to introduce is electrodialysis. Electrodialysis is a membrane process that transports ions from across the semi-permeable membrane under the influence of electric potential. The membranes are either cation or anion selective, which means that only positive or negative ions can pass through. The third method I'm going to introduce is coagulation or flocculation. Coagulation is the chemical reaction that occurs when a coagulant or chemical is added to the water. The coagulant encourages the colloidal material in the water to aggregate into the small aggregates, which is known as flows. Suspended matters is drawn to these flows. So, for flocculation is the slow, gentle mixing of water that encourages the flows to form and grow to a size that allows them to be settled out easily. Last conventional method, which I'm going to introduce as well, is known as adsorption. Adsorption is a common technique for removing the metal ions from the industrial effluent. So here I will going to elaborate from my drawing and also from my understanding. So when a solution containing absorbable solute in the solution comes into contact with the solid, which is highly porous surface membrane. So when they comes into contact, this absorbable solute will absorb at the surface of the solid and becomes concentrated, deposited at the surface. Okay, so after that, this one, the adsorbate solute that absorb at the surface of the solid is known as adsorbate, while the solid providing the surface for the adsorbate to attach is known as adsorbent. So normally some of the adsorbent we use in the industry is activated carbon and also the zeolites to remove the heavy metals such as the iron, ammonium nitrate, manganese, or other heavy metals.
Now, I will explain the properties of fats and oil. Fats mostly derived from animal sources and solid state at room temperature, while oils are mostly derived from plant sources and liquid state at room temperature. The properties of fats and oil depend on their physical and chemical state. For the physical properties, pure fats and oils are colorless, odorless, tasteless, and flavors that associate with some of them are imported by foreign substances that are liquid soluble and have been absorbed by these lipids. Besides, fats and oil are lighter than water, which have in density about 0.8 gram per cm cube. They are also poor conductor of heat and electricity and serve as excellent insulator for the body, slowing the loss of heat through the skin. Moreover, fats and oil can participate in a variety of chemical reactions. This is because they are ester of cholesterol with 3 fatty acids called triglyceride. It is this fatty acid give the functionality to the fat. They can be hydrolyzed in the presence of acid, a base, or specific enzyme known as lipids. Therefore, they can be divided into 4 main groups of fatty acids such as saturated, monounsaturated, polyunsaturated, and trans depending on the process. Fats and oil have been used from ancient times for food preparation or food industry, such as production of edible vegetable oil and animal fat, as well as in non-food application like lamp oil, lubricants, soup manufacturing, and skincare. However, the usage of fats and oil gives an impact towards wastewater treatment. Most of the byproduct of food and food ingredients contain fats and oil, whose main chemical components are free fatty acid. When fats and oil reach the seawater, it cools down and accumulates until it forms a core fixed to the wall of the seawater. With the continuing flow of wastewater, different debris, dirt, and more aggregate around the initial core until they form a solid deposit that plugs drain lines and eventually blocks the sewer. Therefore, it will lead to flooding and contamination of water bodies with sewage. These types of events can have adverse effect on human health and the environment.
Okay, so there are several conventional methods which they use to treat the effluents with high oils and fat content. The first one is physical chemical pre-treatment system. This method is actually known as grease trap method, in which the most common method for them to separate the fats and oil from the wastewater. In general, a fat trap is a rectangular or circular vessel through which wastewater flows under laminar flow condition at the rate that allows the fat particles to rise to the surface by the time they reach the trap's outlet end. In order to break the fat particles emulsion and also the coagulate fat particles, different chemical compounds such as aluminium sulfate, ferric chloride, or even lime can be used. These fat particles can be separated easily by flotation or sedimentation. Next, the second method is known as chemical and enzymatic hydrolysis of the oils and fat. During anaerobic digestion, chemical hydrolysis with NaOH, sodium hydroxide, can be increase the ratio of soluble chemical oxygen demand to total chemical oxygen demand, while decreasing the volatile solid content. The average fat particle size was reduced to 60% of the initial particle size after pre-treatment with the enzyme pancreatic lipase PL250. Most of the slaughterhouse industry use this enzyme to hydrolyze the fat particles. Next, it has been reported that the biological treatments of oils and fat in wastewater under thermophilic conditions is advantageous because most physical properties of the hydrophobic compounds undergo favorable changes at high temperatures. These substances become more accessible to microorganisms and their lipolytic enzymes when they are liquid. With increasing temperature, both diffusion coefficient and fatty acid solubility in the aqueous media increase significantly, thus allowing for better mass transfer. Last but not least, they also use the microorganism to treat the wastewater with high in fats and oils. It involves the addition of bacteria that produce lipase. These bacteria are immobilized on the non-biodegradable support material and immersed in the surface of the grease trap, achieving hydrolysis rate of more than 90%. Aerobacter, aerogenes, and Bacillus subtilis are used in the treatment of the lipid-rich wastewater. Another option for dealing with high fat content in the wastewater is to use surfactants to help the biodegradation by dissolving the fats and oils in the wastewater.
To conclude, pesticides and herbicides are substances that are used to control pests. Industries that use pesticides and herbicides are mainly agriculture. Treatment in wastewater is chemical treatment, such as chlorination, and biological treatment, such as membrane bioreactor. They also have physical and hybrid technologies treatment. Next, we have color. Color is a substance that can transmit its color to the substrate. It can be divided into dye and pigments. In the food industry, they are used to avoid color loss and provide consistency. The treatments of color are coagulation, membrane, absorption, and biological treatment. Other than that, heavy metals are metallic elements that have a high relative density compared to water. An example is chromium and zinc. One of the heavy metals found in the industry is electroplating and metal surface treatments. Heavy metals can be treated in wastewater by chemical precipitation, electrodialysis, coagulation, and adsorption. Lastly, we have oils and fat. Fats are derived from animal sources and solid form, while oil is from plant sources and is liquid form. In industry, they are used in edible vegetable oil production and animal fats production. The treatment of fats and oil are by physical chemical pretreatment systems, chemical and enzymatic hydrolysis, biological treatment under thermophilic conditions, and the use of microorganism surfactants. That's all from us. Thank you. Next is the references.